We're looking at the equation of a straight line. The note on the previous page said that every straight line can be written with this equation, y equals ax plus b. And when it is written like that, the number here, a, stands for its gradient. The number here, b, stands for its y-intercept. Let's have a look at a few examples over here. If we've got y equals 5x minus 2, this 5, the number in front of the x is the gradient. And this number here at the end, minus 2, is the y-intercept, the place where the graph cuts the y-axis. So our first one has got a gradient of 5 and a y-intercept of negative 2. The next one, the number in front of the x is a minus 2. That's its gradient. The number at the end by itself is the place where the graph cuts the y-axis, the y-intercept. Gradient of negative 2 and a y-intercept of positive 8. This one here looks a little bit tricky because there's no number on the end by itself. Or you could say the number on the end is the number 0. Y equals 2x is the same thing as y equals 2x plus 0. And that makes it easy now. So it's got a gradient of 2.5 and it's got a y-intercept of 0. Going to do the same operation backwards because every straight line has got an equation that looks like this. Y equals ax plus b. And the number a is the gradient. The number b represents the y-intercept, the place where the graph cuts the y-axis. So if it's got a gradient of 3 and a y-intercept of 2, it could be written like this. Y equals, it's the gradient times x. So it'll be 3x plus the y-intercept, plus a y-intercept 2. This one, y equals, we want a gradient of minus 2, negative 2x, and a y-intercept of 0, so I'll put plus 0. Now that answer's okay. We needn't have even written that plus 0 on the end. In other words, we could have just written it like this. Y equals negative 2x. It's exactly the same thing, and this answer here is probably a bit neater. And the next one is a gradient of 1 and a y-intercept of 3. Well, I'm going to write it like this. Y equals gradient of 1x plus 3. Now, in algebra, when you've got 1x, you don't even normally write that 1. It's unnecessary. We could have just written that as y equals x plus 3. X means 1x, so that could have alternatively be written as y equals x plus 3. Okay, now the last one is just a little bit tricky. We've got some lines here and we have to work out their equations. Well, when you've got a line here, the y, we need to be able to write down its equation, we need two things, don't we? If we know the gradient and its y-intercept, we can write down its equation. That's what we did here. So what we're going to need to do is find out its gradient and its y-intercept in each case, then we'll know its equation. So to work out the gradient of this line here, it goes through here at minus 5 and it goes through here at 5. I could work out its gradient by doing the rise over the run thing. So the gradient is equal to rise over run. Now if I'm going between here and here, how much do I go up? This is the rise here. and I think you can see that I'm rising from 0 up to 5. The rise will be 5, and from minus 5 along here, that will be the run. And from minus 5 up to 0, that's also a run of 5. So the rise over the run will equal 5 over 5, which equals plus 1. 5 divided by 5 equals 1. Notice also that I'm pleased that worked out to be positive 1, because I want this to have a positive gradient. I'm expecting it to have a positive gradient. Now I've worked out the gradient. Now I need to know the other thing I need to know is the y-intercept. I can see that straight off the graph. The y-intercept of this line, it goes through the y-axis at 5. Now I know the gradient and the y-intercept. I should be able to write its equation down in this form: y equals gradient times x plus y-intercept. Its equation is y equals ax plus b, but I know that the gradient is 1, so y equals 1x plus 5, and you needn't even write that 1. If it's 1 times x, it's just the same thing as x. Y equals x plus 5 is the equation of that line. Let's do the next one. We need to work out its gradient and its y-intercept. Now, if I was travelling between this point and this point on this line, I'm going down, so I'm expecting a negative answer for a start. I want to know the rise and the run. Well, that rise is actually a fall of 3 units, isn't it? I'm going down from level 3 down to level 0. So the rise is -3, and the run, I'm going from 0 up to 1. The run is equal to 1 unit. So the gradient equals the rise over the run, which equals -3 over 1, and -3 divided by 1 is equal to -3. That's the gradient. I also need to know the y-intercept. I can see it straight off my graph. This graph goes through the y-axis at 3. Okay, now I've got a couple of pieces of information. I should be able to write down the equation of the graph, because I know that all straight lines have got an equation that looks something like this: y equals ax plus b. A is the gradient, I know that equals -3. B is the y-intercept, that equals 3. This line has got the equation y equals -3x plus 3.